Today we will discuss about basics of electrical circuits. So the very first part is linear components and non-linear components. Linear components or linear network are those network which follows the concept of proportionality. That is, they are homogeneous system. That is, they are totally predictable and understandable. As you can see from this diagram, that at t is equal to 1 second we can determine voltage. For example, voltage is 1 volt. At t is equal to 2 second, voltage is 2 volt. At t is equal to 3 second, voltage is 3 volt. So accordingly, at t is equal to 4 second, we can say that voltage is nothing but 4 volt. So in linear systems are totally predictable and they are understandable, and their mathematical modeling is easy, and they are homogeneous system. They basically follows they obey Ohm's law, KCL, superposition theorem, etc. But on the other hand, non-linear systems are basically non-homogeneous system. They are non-predictable and their mathematical analysis is difficult. As you can see, at t is equal to 1 second, we can say that voltage is 1 volt, but we can't determine what is the voltage at t is equal to 2 second, what is the voltage at t is equal to 3 second or 4 second. It is not predictable. Okay, so basically non-linear components and non-linear networks does not follow the Ohm's law, KCL and superposition theorem. They does not follow the concept of proportionality. So this is the difference between the linear network and non-linear network. Now basically all our practical components and networks are originally non-linear in nature, but we have to convert them. But to do the mathematical analysis, as you know that engineering is nothing but application of science, we with the help of mathematical modeling. So to do the mathematical analysis of that component which is non-linear in nature, we have to convert it into linear system first. Or any non-linear component or a network can be linearized for a small incremental changes in time. For a small incremental changes in time, any non-linear component can be linearized. Let's the example is, for example, let's say this is there are two graphs. Okay, as you can see, for large incremental changes in time, these two graphs are non-linear in nature. But if we take in this first graph, if we take this small changes in, if we take this small incremental change or small incremental length dx, then we can say this small incremental length is nothing but, this is the pink line or pink curve, and this pink line and pink curve is same as the black curve also. So just for the small incremental time or small incremental change, small incremental length, this curve can be categorized as linear curve. Okay, so the actual curve, which is the black curve, is equal to approximated linearly, that is the pink curve. Black curve and pink curve are same in this case. So yes, the non-linear component can be linearized with the help of this concept, that is by considering small incremental changes in time. So to everything in the world is non-linear, but any non-linear component and network can be linearized for small incremental changes in time. So as you can see, the black curve and pink curve both are same for the small incremental changes in time. So therefore that non-linear curve can be approximated linearly for small incremental changes in time. On the other hand, this is the second curve. As we take large incremental changes in time, so this is what the pink line and this is what the black curve. Black curve is nothing but the actual curve, and pink curve is nothing but the approximated curve. So black curve and pink curve both are not same for big and sudden changes in time. Black curve and pink curve both are not same for big and sudden changes in time. So therefore they, black curve also and pink curve also is non-linear in nature. We have to do the non-linear analysis, but non-linear analysis is difficult. So that's why we are going with this approximate analysis. That is, we have to take small incremental changes in time, and then we have to convert any non-linear network into a linear network. So this is the case. Okay, now the second part which I want to discuss in this basics of electrical circuit is bilateral component and unilateral component. As you can see from this diagram that there is a 2 ohm resistor, and resistor, inductor, capacitor or any sync devices, the basic notation is, if the current is entering into the terminal, then that terminal is considered to be positive. But in the case of active components, the basic notation is, if the current is leaving from that, suppose voltage source is nothing but the active source, if the current is leaving from that source, then that terminal is considered to be positive. These are the standard notations which we have to remember, that in passive element, if the current is entering to the terminal, is considered as positive, and in active element, if the current is leaving from one terminal, that terminal is considered as positive. So this is not, resistor is nothing but the passive component. It is a load. Passive component means it cannot generate the energy, it cannot generate the power, it can only absorb the power, it can only waste the power. So resistor is a passive component. So let's say current is, at first case current is entering from left side. Okay, so this terminal is considered as positive, this terminal is considered as positive, and this terminal is considered as negative. So what is the power absorbed by the resistor? What is the power absorbed by the resistor? It is nothing but I square into R, or we can say V square by R also, or we can say V into I also. So all will give us the same answer. So it is nothing but 72 watt. Similarly, in the case second, let's say that current is entering from right side to left side. Current is entering from right side to left side. So power absorbed is nothing but I square into R, or it is nothing but 72 watts. It is nothing but 72 watts. So the properties of such components are independent to circuit condition. The properties of such components are independent to such conditions. Example is R, L and C. From wherever the current is flowing, power absorbed is same. From wherever the current is flowing, power absorbed is same. So therefore we are getting the same power. So that's why these components comes under the category of bilateral components. Okay, now unilateral component. Example, diode. If we give forward voltage to the diode, then it is forward biased. But if we give reverse voltage to the diode, if we give reverse voltage to the diode, then it is nothing but reverse biased. Okay, so the circuit condition is not same. The circuit condition, the properties of such elements depends upon the circuit condition. In the bilateral, as you can see from the definition, the properties of such components are independent of the circuit condition. If we apply forward voltage or if we apply reverse voltage, that doesn't matter. But in the case of unilateral component, the properties of such element depends upon the circuit condition. That is, if we apply forward voltage, then the diode is forward biased. If we apply reverse voltage, then diode will not conduct, diode will be reverse biased. So examples of the unilateral components are diodes, MOSFETs, transistors, SCRs, etc. Okay, so now active element, third basic is active element and passive element. Active element basically it generates, it delivers, it drives, it energizes, it gives out electrical energy. It basically gives out electrical energy. Example, the notation is current leaving terminal is considered to be as positive in the case of source, as the basic standard conventional rule is source always delivers the power. Therefore, power delivered by the source is considered to be positive. But if somehow source is accepting the power, then it is going opposite to the conventional rule. That's why power absorbed by the source is considered to be negative. Similarly, in the case of passive element, or which is also known as sink, passive element or sink is nothing but which absorbs, dissipate, convert, store, waste electrical energy in any form. Okay, whether it is wasting the electrical energy by converting the electrical energy into heat, example resistor, or by converting the electrical energy into flux, by converting the electrical energy into electrostatic charge, it is wasting. Okay, it is wasting, or it is absorbing, it is converting. Basically, it does not give out the energy. Example, resistance. What resistance does? Resistance basically convert or dissipate the electrical energy in the form of heat. It is converting or dissipating the electrical energy in the form of heat. Inductance store electrical energy in electromagnetic form by establishing the flux. It is storing the electrical energy. Capacitance store and release the electrical energy in electrostatic form by establishing the charge. So it is storing, basically it is charging and discharging. We use charging and discharging name in the case of capacitor, and store and release in the case of inductor. Now the basic notation is current entering terminal is considered to be positive. Source based sink basically, or passive element basically absorbs the power. Therefore, power absorbed by the sink is nothing but considered as positive, and power delivered by the sink, if somehow sink is delivering the power, then that power delivered is considered as negative. So now there are some questions based on these basics which are already being asked in GATE and ESE papers. So I would like to discuss them. Okay, now based on the static VI characteristics, basically what we can say, that if there is suppose we have one component, let's say we have a component A, and graph of that component is symmetrical in first and third quadrant. Like let's say we have a component A and graph of that component is symmetrical, that is mirror image, in first and third quadrant, then we can say it is a mirror image. Then what we say, that it is bilateral. Similarly, if graph of that component A is symmetrical in second and fourth quadrant, that is basically mirror image, it is symmetrical in second and fourth quadrant, then again we can say it is bilateral. But if graph of that component A is not symmetrical in first and in third quadrant, or in second and in fourth quadrant, then it is a asymmetrical graph. Basically it is unilateral. The graph is not symmetrical, it is unilateral. Similarly, to identify that whether the component is active and passive, what we can say, that if the graph of that component lies in first and third quadrant only, then the component is considered as passive element. And if the graph of that element lies in second and fourth quadrant only, then that element is considered to be active element. So how, if there is a question which depends on the basics of linear, non-linear, active and passive, bilateral and unilateral, first what type of questions they have asked is they have given one graph, and from that graph we have to find out that whether that component is active, passive, linear, non-linear, unilateral, bilateral. So how we will find out that whether it is linear and non-linear? It's simple. For that amount of increase in x-axis, there should be same amount of increase in y-axis as well. For example, in this case, for increase in time, voltage is increasing. For increase in time, voltage is increasing. For increase in time, voltage is increasing. But in non-linear network, for increase in time, first time voltage is increasing, but for increase in time, second time voltage is decreasing, then again it is increasing, then again it is decreasing. So it's like non-linear. So that's how we can find out that whether the given component or given element is linear or non-linear. This is the first step. Now second step is how to find whether the system is bilateral and unilateral. To find out that whether the system is bilateral and unilateral, how we can find out that if this system, if the component graph or if the element graph lies in first and second quadrant and it is symmetrical, okay, it is lying in first and third quadrant and it is symmetrical, that is, it is a mirror image, then it is a bilateral. Also if it is lying in second and fourth quadrant and it is symmetrical, and that is, it is mirror image, then also it is bilateral. But if the graph of that element is not symmetrical, like it is not mirror image in first, it is not mirror image in first and third quadrant, and also it is not mirror image in second and fourth quadrant, then it is nothing but unilateral. So this is the method to identify that whether the element is bilateral or unilateral from the graph. Now how to find that whether the element is active or passive from the graph? How to find whether the element is active or passive from the graph? It's easy. That is, if the element graph lies in first and third quadrant, then it is considered as passive, and if the element graph lies in second and fourth quadrant, then it is considered as active. So without any further ado, let's start with the questions. So the static VI first question is, which was already been asked in GATE ESE. The static VI characteristics of a particular component is shown below. The static VI characteristics of a particular component is shown below. From the graph we can see. So we have to find out, the question asked is, we have to find out the nature of the element is, or the nature of the component is. So first thing, is it linear or non-linear? We have to check it first, okay. So for increase in voltage, okay, current is increasing till this time only, current is increasing. So for increase in voltage, till this time only current is increasing, but after further increase in voltage, at some point of time current saturates. So saturation is basically nothing but a non-linear behavior. After some point of time, current becomes saturate. That is, with increase in voltage, current is not increasing, okay. So it is a non-linear. Globally it is a non-linear. Locally, for this part only it is linear, but globally it is non-linear. And also it is lying in first and third quadrant, therefore it is a passive element, and also it is symmetrical in first and third quadrant, therefore it is a bilateral element. So non-linear, passive and bilateral element. This is the answer of the first question. Now second question, we have to find the nature of the component of this graph. As you can see, this is a non-linear graph. Okay, this is a non-linear graph, we can see, because in negative side also, with increase in voltage, with decrease in voltage, current is increasing. With decrease in voltage, current is decreasing. Okay, So it is a non-linear graph. Also, it is neither active nor passive. We can't say that it is individually it is active or individually it is passive. Why? Because it is not lying in first and third quadrant or second and fourth quadrant, but it is a mix of both. That is, it is also lying in first quadrant, that is, it is also lying in first quadrant and also lying in the second quadrant. So therefore it is both active and passive. Now take one example of rechargeable batteries or batteries. Okay, simply batteries, phone batteries example. Okay, so what, when the battery is fully charged in our phones, it is supplying energy to our components to work. But when it is fully discharged, we have to charge that battery by connecting a charger. So what we can say, that that battery is acting as active source for some time, and that battery is acting as passive source for some time. When it is acting as passive source, when the battery has to take the energy from the charger, and when it is acting as an active source, when the battery has to deliver the energy to the mobile components to work. So we can say any active element can be converted into passive, and also it can be converted into active also. But any passive element can't be converted into active. So any passive element, let's say resistor cannot deliver the energy, never. It can only dissipate the energy. If it is storing the energy, after some time it will only dissipate in the form of heat. It cannot deliver the energy. So in such questions, when we get answer as that graph is lying in both first and second quadrant, then we have to say that it is globally active. We have to say that it is globally active, because active can be converted into passive also, but passive elements can't be converted into active. So whenever we are getting these type of answers, that graph is lying in both first and second quadrant, then we have to say that it is active as well as passive, and or we can say that it is globally active. This is the first point to remember. Now it is a unilateral. Why? Because the graph is not symmetrical either in first and third quadrant or in second and fourth quadrant. It is not symmetrical, so therefore it is unilateral. Okay, last question. The nature of the component of these two graphs is, for example, first graph. First of all, it is nothing but the active element. Why? Because it is lying in second and fourth quadrant. It is lying in second and fourth quadrant, therefore it is an active element. Also it is symmetrical graph, therefore it is bilateral. Also, why it is non-linear? Because with the increase in voltage, after some point of time current is decreasing. You can check it. If voltage is increased, current is not linearly increasing. Either current is constant. If voltage is increased, either current is constant or it is decreasing. So you can check from the graph. Current, if linear are those components that if we increase the voltage, the current should also increase, or that is the amount of increase in x-axis should be same as the amount of increase in y-axis. The increment should be same. So this is the answer of first question, that it is active, bilateral and non-linear. Now second question. In this case, as you can see, it is active and passive both. So I've already discussed that whenever we are with these answers, that the element is both active and passive, we have to say that it is globally active. It is, if in the option it is given as okay, it is both active and passive, then mark that option. But if in the option it is given as active, passive, globally active or none, then what we can do? What can we do is we have to mark that C option. If it is MCQ, if we have to select only one correct answer, then globally active is the correct answer. Okay, in such questions. Now as it is not symmetrical, in either in first or third quadrant, neither symmetrical in first and third quadrant, nor in second and fourth quadrant, therefore it is unilateral. And also it is non-linear. Right part is linear, okay, with the increase in voltage, current is increasing. With the increase in voltage, current is increasing. Right part, it is linear. But what about the left part? With the decrease in voltage, current is increasing. With the decrease in voltage, current is increasing in the left side part. So left part is non-linear, right part is linear. So therefore overall we can say that it is non-linear. So answer for this is, that is the nature of the component is both active and passive. If it is not given in the question, mark globally active. Second, it is non-linear. Third, neither, because it is neither in first or third quadrant or in second and fourth quadrant, is not symmetrical. Okay, so therefore it is unilateral. I hope you got it.